Hello and welcome back. In this video, we will solve the 2-sum-2 problem where the input array is sorted. Okay, so before solving this problem, I will highly recommend you to solve the 2-sum problem, which I have a dedicated video on my channel as well. Okay, you can watch it out. All right, so here, let's see what exactly is the problem description. Given a one-indexed array of integers, numbers, okay, that is already sorted in non-descending order, that means ascending order, find two numbers such that they add up to a specific target number, okay. Let these two numbers be this one, so numbers of index 1 and numbers of index 2, where the index 1 and index 2 is lies between 1 and the length of the array. Okay, return the indices of the two numbers index 1 and index 2, each incremented by 1 as an integer array. Okay, so index 1 and index 2 of length 2. So the tests are generated such that there is exactly one solution, okay? And you may not use the same element twice. So your solution must only use constant extra space, okay? So how we can solve this problem? So just don't worry about this one. Your solution must use only constant extra space for now. We will come back to it when we will be discussing about our potential solutions. All right. So here is our examples. So here, as you can see, we are having numbers array 2, 7, 11, 15, and the target is 9. And here we are getting what? We are getting 1 and 2, because here if you just go here, so given a one indexed array, so our arrays starts with the index 1. I do not know why is that, but in this question our arrays start with the index 1, so we are getting 1 and 2 here. The sum of 2 and 7 is 9, therefore index 1 is 1 and index 2 is 2, so return 1 and 2. Okay, and so on and so forth. All right, so let's go to the drawing tool basically inside of Excalibur, and let's see the potential solutions. First of all, let's add some of the numbers here. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and the target sum, let's say it is 11. Okay, so here I will just do target will be 11. All right, so now how we can solve this problem? So in case if you have solved the previous 2-sum problem, right, there the array was not sorted. So what we did basically, we created a hash map, and what we did, we put the numbers inside of the hash map with their index. So something like this: 1 will be 0, 2 will be 1, and so on and so forth. Okay, we push it up, and then we checked if the number which we are looking for. So let's say for this number 4, what we are looking for, so for 4 we are looking for basically 11 minus 4. Okay, so we are looking for this one. So if I just do that, so it will be 7. So we are looking for 7, and if 7 is inside of this hash map basically, then we are returning our solution in that regard. Okay, so this is one potential solution. Okay, but as you can see, it needs the extra memory. Okay, so now the thing is, can we do a little bit better? And once again, I want to point out here is that whenever we are given a sorted array or a sorted string, that indicates something. Okay, can we use the sorted property? And in this case, we can use the sorted property by using the two pointers approach. All right. So what we can do here inside of the two pointers approach, we can add a pointer here and we can add a pointer at the last element. So at the first element and the last element. Okay. So now we will check. What we will check? We will check the sum of these two elements here. Okay. So what we will do? So current sum will be this element which is currently 1 plus this element which is 9. All right, which equals to 10. Okay, now here is our current sum and the target is 11. Now we will check if our current sum is less than or greater than our target sum. Okay, so if it is equals to the target sum, then we are having our solution at that particular moment, right? But currently right now 10 is less than 11. So if 10 is less than 11, then what we want to do? We want to increase, right? We want to increase our current sum. So how we can increase our current sum? So we are having these two pointers here, one of them here, one of them here. So what exactly we can do? We can shift our pointers. Now the question is which pointer to shift. Okay, so it will totally depend on this sort of condition. So currently 10 is less than 11, right? So then if we want to make a bigger number, then what we want to do? We want to basically have to move the pointer. So here we have to move the left pointer to here. Okay, so as you can see, if I just do something like this, okay, I just realized that for our target, if I just move this one here, then we will be having our target, right? Okay, so 9 plus 2 is 11. So we will be having our target. So let's not do 11. Let's do something like, what we can do? Let's do something like 13. Okay, so let's do something like this. So our target is 13. Okay, so here we can do 13 so that our algorithm has a little bit more room to grow. Okay, then so if I just do something like this, okay, so our pointer was here, right? And 10 is also less than 13. So then we want a bigger number. So how we can get a bigger number? So if I just move the right pointer to the left, then what will happen? The array is already sorted. So we will get a smaller number there, right? And this is indeed the case. So 1 plus 8 will be 9. So that will be smaller. So we want to have a bigger number. Then in that case, we have to move the left pointer to the right. Okay, so let's do something like this. Now, as you can see here, so currently right now, we are having 2. Okay, so 2 plus we are having 9, which is 11. Okay, and 11 is also less than 13. All right, so 11 is also less than 13. Okay, now if that is the case, once again we will move our left pointer, and in case if we are getting a number which is greater than 13 basically, so then we will move our right pointer here. Okay, so currently right now we are having, so we are having 3 here. Okay, so here I will just get rid of this one, and this one. So currently right now we are having 3. Okay, all right, so 3 plus what we are having 9 at the right pointer. Then what we are doing, we are getting 12, and 12 is also less than 13. Okay, all right, 12 is also less than 13. So for the sake of this video, what I'll do, I'll just get rid of the 4 here. Okay. So if I just get rid of the 4 there, then this algorithm will grow a little bit more. All right. So we are having 12 here. Okay. So 12 is less than 13. Okay, which is our target. All right. So in that case, what we will do, once again, we will move our pointer here from here to here. Okay. So now we are having 5 plus 9, which is equals to 14. Okay. So 14 currently right now is greater than 13, right? So if that is greater than, then what we want to do, we want to make our current sum a little bit smaller, right? So in that case, we have to move our right pointer to the left. So let me just grab it here. Okay, so yeah. So as you can see, we are moving our right pointer to the left here as well. So now, if I just do something like this, okay, so now as you can see, we are having 5, which is at the left pointer, plus we are having 8, which is equals to 13. Okay, so 13 equals to 13. And then what we can do, we can basically return the left index. So return the left index plus 1 inside of an array basically, and the right plus 1. Why plus 1? Because array in our case is 1 indexed. That is why we are returning this one. Okay, I hope that makes sense. So in that way, we are able to construct a algorithm which is basically more efficient, more storage efficient and time efficient as well. So now let's talk about the time complexity. The time complexity here, as you can see, that will be big O of n, where n is the number of elements inside of the array, input array. Okay, and like in the worst case, basically we have to traverse through all of the elements, right? So what exactly is the space complexity? Okay, the space complexity here is big O of 1. Okay, and that satisfied our question as well, right? So if I just go to our question, as you can see here, your solution must use only constant extra space. So here our solution is basically using the constant space, right? We are not creating a new array or something like that. All right, so now let's jump into the code and code it up. All right, we are inside of Leetcode right now. So now let's declare our pointers. So left pointer, that will be at 0, and right pointer, that will be at the last element, right? So how we can get the last element? So length of the numbers, which is our input array, minus 1. All right, now we will run our while loop. While left is less than right. Okay, all right, so we will calculate our current sum equals to the numbers of the left and the numbers of the right. Okay, so numbers in the left pointer and number in the right pointer. Okay, now we will check if the current sum which we have is less than the target. We are having target from here. Okay, if that is the case, then what exactly we want to do? We want to basically increase our current sum, and to increase the current sum, we have to move our left pointer. Left plus equals to 1. if the current sum is greater than the target, okay, then we want to make our current sum a little bit smaller, and that is why we will decrease the right pointer, right? Right minus equals to 1. All right. Else, what exactly is the else case? Else case is basically when our current sum and the target is equal. Okay, then we want to return the left plus 1 and then right plus 1. Okay, and here we are basically guaranteed to find a solution. But in case if we do not find a solution after running our while loop, then return an empty array. Okay, all right. So now let's discuss about the time and the space complexity once again. The time complexity, that will be the big O of n, because we are basically looping over the elements only once. What exactly is the space complexity? Space complexity, that will be the big O of 1, because we are not allocating basically new arrays or hash maps. Here you might say like, hey, we are creating the left and the right variables. You are right. And the variables like these ones, the numbers, take constant space. I hope that makes sense. All right. So this is basically our solution here. Okay. All right. All right. So this is our solution here. Okay. So if I just do something like this. So now let's run this program here. Okay, as you can see here, our test cases are passed. Okay, and here if I just zoom out a little bit. Okay, all right. So if I just save this one, so Leetcode is having some problems. So let me just run it once again. All right, now I can scroll. Okay, all right. So Leetcode was having some issues. So currently right now, so this is our whole code basically. So if I just zoom out a little bit, okay, in that way, it is fitting in our screen, right? All right. So if I can do that, okay, so this is our solution here. All right. And now I can submit it. Okay. So as you can see, this is quite efficient as well. Okay. All right. So in this video, we have learned how to solve the 2-sum 2 when the input array is sorted. Okay. Awesome.